Hello my students, how are you? Grade 4? Today we'll explain lesson number 2, topic number 7, factors. Do you remember we start last lesson explain about the multiples between two numbers to get factors of number like 24, equivalent the number of factors we can write 2 times 12, 4 times 6, and so on. Now we will explain the factors. You can use multiplication to find the factor pairs for a whole number, and you can also make sense of problems. Look, Jared has 20 flowers. He wants us to plant all of the flowers in equal rows in his garden. What are the different ways Jared can arrange flowers equal row? We can find the factors of 20. We know 20 equivalent to 2 times 10, 4 times 5, and 1 times 20. And then we have three solutions about this example. First solution, 1 times 20 equal 20. And 2 times 10, 20, and also 4 times 5. You can draw like this, horizontal, and 2 rows, each row contains of 10 elements, or 4 rows, each row contains of 5 elements, like this. Or you can color the grid, which he gave you as example. You can color this. We have 1 times 20, 2 times 10, and 4 times 5. You have three solutions about this question. Look back, make sense and previous. How can you check you have found all different ways Drake can plant his flowers? Simple answer here start with 1 row flowers. 1 times 20 equal 20. Try 2 rows of flowers. 2 times 10, 20. 3 rows of flowers. 4 rows of 4 flowers. 4 times 5, 20. So on until you get to 20 rows of flowers. 20 times 1 is 20. Okay, understood? How can you use multiplication to find the factors of a number? She wants to arrange her action figures in equal size group. What are all the ways you can arrange her action figures? We have 16. We know 16 equal 4 times 4, or 8 times 2, or 1 times 16. Well, then we have three solutions about this. 4 groups of 4 elements, or 8 groups of 2 elements, 1 group of 16 elements. How do you know that are no other factors of 16 other than 1, 2, 4, 16? Let's explain. Simple answer, there are no factors of 16 because there are no other factor pairs other than 1, 16, 2, 8, 4, and 4 that have a product of 16. Do you understand? Jean put 7 more action figures. Okay, what a different equal size groups he can make. We know 23 product by 1 equal 23 because 23 is odd numbers. Any odd number, or here odd number and prime number also. Then 23 is prime number. You know 23 can divide it by itself and 1 only. We have 2 factors of 23. Then 23 is a factor of itself, and 23 we call it prime number. And factors of 2, it will be 1 and 2. 1 times 2 equal 2. Factors 20, 1 times 20, 2 times 10, 4 times 5. What factor beside 1 does every even number have? It will be 2. 2 is the even number. Any even number can divide it by 2. 2 is the only even prime number because 2 can divide it by 1 and itself only has 2 factors. Then 2 is the smallest prime factors, or the smallest number of even. Also, any even number can divide it by 2 because we can divide it by 2 like an even number like 0, 2, 4, 6, 8. And the number here 28 equal 1 times 28, 2 times 14, 4 times 7. 54 equal 1 times 54. 6 times 9, 2 times 27, 3 times 18. Now we can write the factors of 34. 34 divided by 1, 34, 2, and 17. Also 39 divided by 1 and 39. 61 divided by 1 and 61. 14 divided by 1 and 14, 2 and 7. 22 divided by 1 can divide it by 2, can be 11 itself. These all factors. Also 32, we have all factors about this, and 83 is a good and prime number. 83 we called it prime number, divided by itself and 1 only, has 2 factors. 25 divided by 1, 5 and 5. We can't repeat 5 here because we must write the factors only. 15 is a prime number, can divide by 1 and 19. 63, 7 times 9 equals 63. 1 times 63, 3 times 21. Solving the problem. Look at here, this question first. Erin wanted to list the factors of 88. She writes 2, 4, 11, 22, 44. What is the number was here and 88? Is Erin correct or not? We know also 4 product by 22, 4 times 22, and 2 times what? 2 times 44, and 11 times 4, 11 times 8 equal 88, 4 times 22. Okay, then this number also can divide by what? Divided by 1. You don't write 1 here. Okay, 1 also is a factor because factor 1 is a factor of every number. Next question. The roots of plant are often the largest part of the plant. Winter ray can grow combined root tissue well over 984,000 feet in length. Write his number in expanded form. We can write 900,000 plus 80,000 plus 4,000. A restaurant receives a shipment of 5,000 ketchup packets in 1 week. They use 1,824 packets. The next week, they use 2,352 packets. Write and solve equations to find how many ketchup packets the restaurant has left. We can collect together and the result subtract from 5,000. Okay, collect together 1,824 plus 2,352. Result will be 4,176. And the result subtract from 5,000 will be 124. Look at the steps about the difference here. We can write 5,000 subtract by the number 4,176. We can put 1, it will be 4, it will be 10, 10 minus 1, 9. Put 1, it will be 10, 10 minus 6 equal 4, 9 minus 7 equal 2, 9 minus 1 equal 8. And the result will be 824. Next question. Any number that has 9 factor also 3 factors, true or false? The simple answer 9 here is a factor, then 3 because 9 can divide by itself, divided by 1, divided by 3. We have 3 factors of 9. Higher order thinking. Look at here's the question. A mother, look at this, we have the length was 12 feet. Mother made it chart to the right 3 times as long as her baby minutes. How long is her baby minutes, right? And solve the equation. 3 times what equal 12, 3 times 4. If a blue wall is 9 times as long as minutes shown, then the result will be 9 product by 12. It will be 108. And then find the difference between two lengths. 108 subtract by 12, it will be 96. Practice which number 3 and 29 has of its factor. 87, we can product between two numbers, 29 by 3. We can product 29 by 3, okay? 3 times 9, 27, write 7 and carry up 2, 2 times 3, 6 plus 2 equal 8. A store manager wants to display 45 cans of soup in an array. Which of the following shows 3 ways the cans could be displayed? We have 5 times 9, 45, 15 times 3, 45, 5 times 9, 45.